Okay. Thanks, Arena, and thanks for everyone that is here today. Like Arena said, I see this as an informal talk. So if you have any questions, just go ahead and speak up or raise your hand or whatever, and then we can talk about things as we go along. Otherwise, I'll get started here. So first, I just want to mention what's happening at the APS. And as you know, the APS has been down for over a year. It went down in April of 2023, and with the goal of implementing this multi-bend Acromat lattice or MBA lattice. And the goal there was to reduce the horizontal beam size significantly, as you can see in the image here. So to eventually make it more symmetric. And that required quite a bit of work, obviously. It was not just swapping out a few components, it was all the components in the ring. So as you can see, they ripped everything out of the tunnel or out of the ring here, and had to replace everything through the course of the year, and revalidate everything, survey things into place, and bake things out. And it was a lot of effort with all the different groups at the APS.
So Rob, if I could interrupt for a second.
Sure.
Do you have illustrations that you're actually thinking about or talking about? Would you need to share your screen so we can see that?
Oh, you don't see the screen?
No.
Oh,
I see the screen.
I see the screen.
I see the screen.
Yeah, I see the screen.
Okay. I'm sorry. They gave us a new version of Zoom. There's 2 tabs on it. Defaults to the one where I see you talking. Sorry about that. Sorry about the interruption. I got it.
So you can see it now?
You can see it now?
Yes, I can see it now.
Okay.
I had to go to a different tab, which is not the one by default. Sorry again for the interruption.
All right. I'm still on the first slide. Well, I had an introductory slide here, but now this is the slide here where they've, as I was saying, they've stripped everything out of the ring and had to put all new equipment in there and bake everything out, hook it up, test it, survey it, everything that's required, and with the goal of getting the the MBA lattice implemented. Along with that, several things are changing. And if we look on the lower right table, this is from an older document, the design document from 2019. I find this document to be quite helpful. It explains a lot of the details, and it goes through some of the calculations of what their plan was and everything. And that, I think, is accessible outside of the APS at the website down below here. So if you're interested in those details, you can go into that document and read a little bit more about it. But the things I want to point out here are there's 3 columns. The furthest one to the right is before the APSU, the parameters or the important parameters, and then the 2 operating modes that they're going to offer. Now, these operating modes are referred to as a timing mode, which refers to the number of bunches, the 48 bunch mode, and a brightness, or sometimes they call it high brightness mode, which is going to be 324 bunch mode. So previously we had a 24 bunches, 324 and hybrid, and now it's only going to be the 48 bunch and 324 bunch mode. There's no more hybrid, which is unfortunate for BioCARS because we did rely on that because it had a much higher current in a single bunch, 16 milliamp versus the 4 milliamp that we would see in the 24 bunch mode. Another big change with the MBA lattice is that they're not going to have a top-up mode of operation anymore. And if you're not familiar with how that works, as the electrons go around the ring, they decay and we lose ring current. To counter that, they were periodically injecting a little bit of current into the smallest bunch to maintain constant current for extended periods. The top up is gone, and they've changed that to a swap out operation, which means that they're going to dump whatever the bunch is probably the lowest and insert a completely new bunch with all the current already in that bunch. One limitation to that is that the highest current they can go to is 4 milliamps per bunch, which is the same as what we had before in the 24 bunch mode, but it's not expected to be able to go any higher than that per single bunch. So that's going to be a different form of operation that we're going to have to see how well that works. Beam stability, I have different concerns about that. They say it should be stable as it was before, but we'll have to see what happens. As I mentioned earlier, that's a smaller horizontal beam size and divergence, and you can see that in the table over here if we compare some numbers. So this the last column's before, and then these two are for the two new operating modes. You can see that they're significantly smaller than what we had before. As far as the vertical beam size, that really won't change significantly. You know, the timing mode really has very similar parameters, and the high brightness mode, it is a little bit smaller. So we should have in that mode of operation a little bit smaller beam size is what we're expecting to see. So one other thing that's I don't think listed in this table is another change is the longer pulse duration. So we in 24 bunch mode, previously we had 100 picosecond full width half max for the size of the pulse. Now that's going to be around 250, 260 picosecond range. So BioCARS will lose a little bit of time resolution on the ultra fast experiments. We go to, so that's was the plan. And then they got everything installed, and they got first beam or first electron circulating in the ring on April 10th of this year. And then a little over 2 weeks later, they did the first swap out injection, which is shown here on the plot on the upper right. They're able to, it was low current, 1 milliamp in the bunch at this point, but they were successfully doing swap out injection. In the beginning, they worked 24 hours a day doing a lot of commissioning, and at one point they had to keep us from going out on the floor because they had to do radiation studies and try to identify, if there's any problems for radiation issues out on the floor. But they finished that about a month ago, I think it was, and they've been slowly ramping up the current. And just most recently, they got up to about 60 milliamps, which you can see in the plot here. They've been slowly bumping it up. And so and that's mainly, from my understanding, limited to the vacuum levels in the ring. And this was anticipated from the beginning that, even though they baked everything out, they still weren't going to achieve the high current without doing some internal conditioning. So what they've been doing lately is going as high current as they can tolerate at night and let it bake out through the night. And then during the day, the 2 shifts is when they do the commissioning of the beam. And that's still ongoing. And for the most part, I'd say that's going quite well. They did have a few problems where they had a failure of the septum magnet, and that took a week to swap out. And then unfortunately I think it was Sunday night, they had another vacuum issue, so we haven't had any beam this week. And so there's been some delays, not totally unexpected, but it does delay the commissioning. But they were able to get first X-ray beam at the APS diagnostic beam line, and they used that beam line for just measuring beam sizes and I don't know what else, I guess, but they were able to get first beam, and so things are progressing. So that's good news. If you want to kind of stay up to date on some of this, I recommend looking at the APS web page. There's a upgrade page there that gives some more information about what's currently happening. It doesn't give a lot of details as far as the data stuff, but as I mentioned earlier, there is a design document that's from 2019, but it does explain a lot of the implementation of this and the calculations and everything went through. And I found that helpful when I had particular questions about things. Another thing I noticed there is they have an FAQ section, which has been helpful to answer some other questions that weren't in the other documents. And so if you're interested in that, I recommend going back there and taking a look at that. So that's what the plan was and where they're at now. And they've been discussing with us the plan for the future and how to bring up all the beam lines and what the plan is. They've been very reluctant to give out too much information because things have slipped in the schedule already, and they're anticipating some more slips in the schedule. And so, they don't even want to publish these things on the web page because they you know, they don't want to be locked into anything in particular for a schedule. And so they frequently describe these things as being very aggressive schedule, assuming nothing, basically meaning nothing's would go wrong, and they'll stick to this schedule. But they also say the schedule's probably going to change. So it probably will slip at least a few more weeks from what we see here. But this is the schedule that they gave us, I think, a little over a week ago. So on the upper right here shows all of the beam lines and the order that they're planning on bringing them back online. And as you can see, the red box here is BioCARS, 14 ID. We're roughly in the middle of the pack. And if we go by the time frame that they're giving us there, our shielding verification should start towards the end of July, early August. Then the beam goes down for, I think, 5-6 weeks for their maintenance period. And then if everything is going well, we can start our technical commissioning if we're finished with the shielding verification. They've allotted us about a month to do that. We'll see if it takes that long or not. You know, we just have to see where we're at. And then we'll move into a scientific commissioning of about another month or so. And then if all goes well, we want to be able to bring in the general users for the last month of the run. But again, this is very tentative. You know, that's almost 6 months out, and we're not quite sure if this is going to hold true. Everyone around here and at other sectors believe this is going to slip some more. So don't hold us to this. But let's just assume that this all goes as planned. When we get back into our general user program, that doesn't necessarily mean we're going to be at full beam. As you can see on the lower left here, they're ramping up the ring current slowly over several runs. This summer they said 50 milliamps. Well, technically they're already at 60, so that should be fine. I think they'll get to 100 milliamps for the fall run. I think they're on track for that. But again, things could change. And then 150 in the spring run and 200 by next summer. As far as the bunch modes, they're really focusing on the 324 bunch mode for now. They've said that 48 bunch mode is a little more difficult and they need more experience with it to offer it. So I'm guessing they're not going to have anything for 48 bunch mode in the fall, but maybe they'll do a little bit of time with that. I am not sure. But it should be at least present a little bit with 48 bunch mode later on, but there's a stipulation of some limitations with the current per bunch. They believe that they're only going to get about 2.7 milliamps per bunch initially when they're in 48 bunch mode. So that means the total ring current will be around 130 in the beginning. And they said they still plan on bringing up the bunch current to 4 milliamps eventually, but they need more experience, and they said they may have to do some hardware upgrades to make that happen, and they didn't really give a timeline for that. So sometime, you know, probably a year from now, hopefully 48 bunch mode will be at 200 milliamp. One common question we get is, you know, how much 48 bunch mode there is versus 324, and the APS has really not given us, you know, a definitive answer to that. They really say it depends, you know, so it depends on how well the ring is running, what sort of demand there is for the two modes. And they've nominally, you know, mentioned 48 bunch at 40% and 324 at 60, but you know, that's another thing that could change. You know, everything could change at this point. And so we'll just kind of have to wait and see how things go as we get further along in this process. So that's the APS side of things. What has changed at BioCARS? Well, we've because of the change in the ring, we have to change our undulators. We previously had the U23 and U27 undulators collinear with each other, and but we're switching those to the U21 undulators. And the main consequence of that is a smaller energy range. So previously we had about 6.5 to 19 keV. That'll drop to about 8.5 to 15 keV, which anticipate still operating at 12 kV in the end, and so that shouldn't affect us too much. One of the undulators has been installed, and the second one is scheduled to be installed during this downtime. If I go back to the previous slide here, that's this 6 weeks time frame here is when they're planning on installing the second undulator. So hopefully by the fall run, we'll have both of those in place, and we'll have everything commissioned and ready to go. Other things that are changing at BioCARS is the Ulick chopper. The change in the pulse mode from 24 to 48 bunch mode means that our current chopper could not isolate a single bunch in that mode, because they're splitting the amount of time between the bunches to half the time. That's what it was before. To deal with that, we've had to upgrade the tunnel on our choppers to just make it smaller, and that's currently this is a picture of the tunnel here. It's actually on both sides, and that's vertically. That's going to be made a little bit smaller. That is in the process of being finished right now at Ulick. It was supposed to be shipped this month, but I was just told earlier this week that they've run into some problems with manufacturing this rotor. So I didn't get a timeline exactly when it's going to be here, but I'm hoping it'll be here like September 1st. So that would be just in time to install it for commissioning. But again, that could be delayed a little bit more, and that would affect, how things come up for us. We can do some commissioning without it, and we will in the beginning, but eventually we, of course, need it for our experiments. So we'll see how that all comes together. Most of the instrumentation on the beamline really doesn't have to change except for the chopper. We do need to add an additional backstop on the downstream end of 14 IDB. This is because we're going to experience some higher heat loads because we had to redo the calculations to verify all the components on the beamline, and I don't know if any of you remember, but we currently have this V-shaped beam stop on the downstream end. That is not valid anymore for the pink beam, our focused pink beam. So we have to add an additional backstop to stop the focused pink beam. And we're hoping that that's going to be installed late June, early July. We're going through the final process of getting the final design report approved. We already have conditional approval, but we need to go back and fix a little details and stuff like that. And we're in the process of, or the APS is in the process of updating that document right now. But that, of course, needs to be in place before we can do our shielding verification at the end of July. And so we're on track to get that done, but hopefully there won't be any more delays in that. Other things on the beamline, a bit smaller, but also important. We've been replacing computers and updating all the operating systems to a newer version of Red Hat. And, that's not difficult, of course, but it takes time, and there's always hiccups to get things reconfigured and stuff. So we have that done. We've been updating some of the hardware, such as CPU cards and our VME crates and a few other components on the beamline for like reading out voltages and ADCs and stuff like that have been replaced. We've upgraded a lot of the software. So EPIX is at the latest version now. If you're not familiar with EPIX, is what we use to communicate with most of the beamline devices. And this allows us to take advantage of some of the latest developments that occur with different instrumentation or new features in the code by updating the version of EPIX. Another big update is the Python code. We use Python for most of our data collection interfaces, Lowy Collect and other interfaces. This was all based on Lowy version 2.7, which is quite old and I think was stopped supported in 2020, I believe. And so we migrated everything to work with Python 3.11, which is close to the latest version. And we have quite a bit of that done. There's a few little things that still need to be done with that, but that seems to be progressing. So that's what we've changed at hardware and software side. at BioCARS, but I think most people are interested in, how does that affect their experiments in the end? Not only when can we get in to do the experiments, but what to expect when you get here. And of course, we've done some calculations, and so I have a table here to compare what numbers we had before the APSU and after the APSU. And this is all assuming 12 keV, both undulators in place. I'm mainly focusing on like the 24 and 48 bunch mode of operation, but I guess I do have a little more information in there. So the first several lines here I've talked about already: pulse duration, ring current, bunch modes, and such. But I think a lot of people are more interested in, what bandwidth and flux and beam sizes. So I'll focus on those parts here in the on this table. For our standard mode of operation, our crystallography mode, previously we would have a bandwidth around 5.5%, and and that's what we're expecting to have with the new undulators and after the APSU. So bandwidth wise, we're expecting about the same there. For our solution scattering experiments, we typically we want reduced bandwidth, and we can do that by reducing our white beam slits, and we typically operate in the 2.5% to 3% bandwidth range for that. And previously, when we reduced the slits, of course, you lose some flux, but it also cut into the peak intensity, and that would get reduced by about 40% or so. With the APS, when we do reduce the slit size, with the APSU, we reduce the slit size to around 3%. Things are going to be a little different. We shouldn't see a significant peak intensity loss, which is beneficial. And that's due to, if you look at the undulator spectrums down here in the lower left, we have the U23, which is what we had previously, and a U21, which we'll have with the APSU. And the big change here is this long low energy tail really is minimized with the MBA lattice and the U21 undulators. So that allows us to have a little more flux at 3% for the solution scattering experiments, which is nice. So now talking about the flux per pulse, well, I like to talk about the flux in two different ways: the flux per single pulse, and other experiments are more concerned about a pulse train. And previously, what we frequently would use is this 3.6 microsecond exposure time, which we referred to previously as 24 bunch mode. And but I'm just kind of using that as a reference point. Let's first look at the single pulse flux. Well, hybrid mode was nice, 3 times 10 to the 10, but of course we don't have any hybrid mode, so that's out. The crystallography mode previously was about 8 times 10 to the 9 photons per pulse in 24 bunch mode. Unfortunately, we're going to have a little bit less flux in the crystallography mode with 5.5% bandwidth and 48 bunch mode. The solution scattering setup fares a little bit better. We have previously would have about 3.3 times 10 to the 9 photons per pulse in 24 bunch mode, and that should be about the same. I think mainly due to the peak shape of the undulator spectrum. So we have a little bit more flux in that peak, so we're not really losing as much when we close down the white beam slits. So that's the single pulse flux intensity. If we look at the multiple bunches for 3.6 microsecond exposure time, this is what we previously had, this many photons in 24 bunch mode for the crystallography mode and solution scattering mode. And this is what we're expecting for the same exposure time. You would think double that, and that's double what we had before, and that's true for the crystallography, but not for the, that's true for the solution scattering, but not the crystallography mode, because we don't have as much flux in a single pulse with that particular bandwidth. So we probably won't be doing 3.6 microsecond exposures for your experiments, because that might be too much flux. We'll have to decide that on individual experiments. We can, adjust our Eulick chopper and, reduce the intensity back to this level if you want. Then the exposure time is going to be 1.8 microseconds or whatever we set it to be. And, that'll be kind of dependent on what your sample can handle and what we want to do for your experiments. So we do have more flux in a little bit shorter exposure time, which is nice. Same thing can be said about this 7.2 microsecond flux, but I'm not going to talk about that. I guess it's the same. The other big question that people have is, what about the minimum beam size? Previously, we could get down to about 20 by 20 microns for the horizontal and vertical focusing, and we were able to, of course, to have a bigger beam size than that, but the smallest beam size was 20 by 20. In the future, with the changes with the MBA lattice, we should definitely be able to get much smaller in the horizontal. And I just say less than 10 microns because I'm not quite sure of the quality of the horizontal mirror at this point. I'm sure it's going to be less than 10 for the horizontal, but we have to measure that during commissioning and figure that out. For 48 bunch mode, the vertical beam size is expected to be about the same as before, so 20 microns. But if we go to the 324 bunch mode, we should definitely see 10 microns or below there as well. So smaller beam size after the APSU with similar fluxes as before. Otherwise, hardware-wise, the detectors, that's not going to change. The EPIC should be available for certain experiments, and of course, we're going to be doing solution scattering and all the same experiments as before. So that covers what we expect to see when the beam comes back and once we get everything recommissioned on the beam line. But there's also changes that are happening at the APS that I should mention as well. We talked a little bit about this before. We gave this presentation about some of the issues with the APS. I strongly recommend that you go to the APS user information webpage, because they're going to require you to register and set up a domain account. Our experience with that so far is most people are having problems, and they say that they're going to set it up automatically for you, and you end up having to contact them. I don't know if they've worked through those issues or not, but I strongly recommend starting that process sooner than later, so that we're ready for when it's time to start submitting proposals. Now, I also noticed on the page that I forgot about this until just recently, that Real ID is required for site access to Argonne. So if you don't have that in place yet, I would get started on that sooner than later. Other information that you'll see on this web page is links to the universal proposal system. So they've replaced the proposal system with one that's a collaboration between Argonne, Slack, and Brookhaven. This is up and running. We are still learning how to use it ourselves. So I would get your account set up and maybe log in and play with it. And we can maybe answer a few questions, but it's probably better to go to Jackie Flood for the administrator of this, and she would be able to answer questions better than us. I forgot to mention this earlier, but I'll say it here as well. For the commissioning, the scientific commissioning part of this, we don't know exactly when this is going to happen and how much current we're going to have, which bunch mode or anything. So if you're interested in participating in the scientific commissioning phase, let us know beforehand before you submit a proposal, and we'll decide, if it's appropriate to, submit a proposal. And we may not even have you submit a proposal. Maybe we'll just add you to our ESAF, depending on how things go this fall. But we're anticipating that everything should be operational for the next run in spring. So definitely, if you're interested, please submit a proposal for the 2025 run. And everything should be ready to go by then. We may not, at that point, like I said earlier, we probably only are going to be at 150 milliamp, but we're getting closer. Another thing I should mention that's different out on the floor is dosimeters. We need to start wearing dosimeters again. And so we'll have to make sure that you get issued one and before you get here, and that it's waiting for you when you get here, because you can't go out on the floor without one. And this will give you access to most of the places on the floor, any place that you really need to be. There are some restricted areas, but those should be blocked off by the time we start bringing users in. So, so there's some changes on the APS side here that you should be aware of. And I would start working on some of that sooner than later. Otherwise, I guess that's all I was planning on talking about today. I think it was the last slide. Are there any questions that people have? Any concerns? Something I need to expand on? I can do that now. Okay, yeah.
Yeah, Rob, maybe one question. Are there any updates on the beamline control in terms of like the FPGA system?
We're going to start out with the old version of the FPGA. We are planning on having Phil and Friedrich, well, Phil come out, but Friedrich remotely to get the new version of the FPGA working again, and we want to implement more of that on the beamline. But initially, it's going to be the old version of the FPGA. That's what we're familiar with. We know how it works, and that it's just easier for us to get started and we're most familiar with.
All right, fair enough. Thank you.
Yeah. Any other questions?
Well, I'm interested in this EPIX detector. Is there any documentation about the software you can share with us?
I do have a little bit. I haven't looked. Oops, I'm there. I guess that was up this way. I have some other slides here, but yeah, we do have this available. We haven't fully implemented this yet, but I'm working on that this summer. And I do have some documentation that I can send you. I haven't looked at it lately, but I'll get you something, okay?
Okay, thanks.
Any other questions?
Rob, is that picture you showed about the EPEX one that was taken from BioCARS?
That
actually looks
particular
like-
one, the diffraction image or the
The
detector?
the diffraction image, is that?
Yeah, that was actually that was a PYP crystal, yes, that at BioCARS. And this, if I go back here, this is a, oh, how do I get the movie going? Maybe I gotta, oh, there we go. This is one module when they first did some testing here of PY crystal. It wasn't the best crystal, but it's a series of images that we collected. And so yes, we have been able to collect some data with it. We haven't completely, I haven't had a chance to get all the data processing going. I guess you can see the single module. I have a picture of it over there. But then now this is what we have. This isn't actually on our beamline, I guess, but this is a picture of it. And it actually has a cover over the top, the Mylar cover and stuff, so you don't see all this. But we do have that available. We have been working with Rayonics on the data collection software, and I do need to work on that a little bit more this summer before that's fully available. But I'm hoping that can be used for some experiments later this fall, or well, with commissioning, maybe not. Maybe it'll be in the spring now, but we'll see.
So this is effectively a 4x4 array of modules then, and each module looks like a 2x2 array?
Yes. Correct. So.
But its overall dimensions is approximately half that of the Rayonics, as I recall.
I've forgotten the numbers. I don't have them in front of me, but I want to say it's like
Approximately,
our
yeah.
CCD size.
2.1 megapixel in total.
Yeah, 2.1 megapixel, yes.
Yeah, but actual size is smaller. It's not ideal
Right, the
detector
chamber-
for solution scattering if this is what we are trying to figure it out.
Right.
Well, to get the same range of Q, we have to bring it twice closer
Yeah,
to
but
have the same
this is
range as the Rayonics.
Huge chamber, and you can see the chips inside, and so it's a little difficult if you I guess my plan was to mount this in front of the Rayonics and only use this. I think you were hoping to mount it to the side and collect data with both detectors to
Well,
get.
no, what I had in mind was doing what, as you say, mounted in front, but then possibly rotating it 45 degrees and then using one of the corner
Oh.
tips to be on center. And
Yes,
that way you can get the full range of Q, but it's not going to be a symmetric range. But
right.
that way, but this picture is useful because it gives one a sense for how much dead air you have around there. So to get accurate wax scattering from that will be a bit more challenging because all these modules will have to be properly normalized with respect to each other.
Right.
This is not gap free.
Right. Yep.
Yeah, but isn't this like Rayonics will be taking care of that, Rob?
Well, this is a bit of a problem. This was we got this detector from Slack, and they didn't provide the greatest software. In fact, each quadrant had to have a separate software package running at the same time to read this out. So it was a bit of a mess. Rayonics was interested in this detector. In fact, they want to commercialize this. And so they agreed to provide some software which made running the detector and integrating it into the beamline easier, and they've done that. Unfortunately, they've decided to change this detector, and so now their support isn't going to be there anymore because they're changing the electronics, they're redesigning things, and so it's even though it'll look the same, I guess all the electronics behind it are going to be different. So there's not going to be any long-term Rayonic support for this. So I'm a little worried about the long-term support of this detector, but we'll use it as much as we can. So
I think that makes it all the more important to provide Friedrich as much detailed as information as
Sure.
possible, because once you can read it, know how to read it, then in terms of long-term support, it's basically the hardware side of things. Software, we could probably get something working that
Right.
that would be sustainable for the duration of the detector lasts anyway.
Yes. So
So-
okay.
So Ron, I maybe have a couple questions about this swap out approach. So it seems to me the real challenge is in the past they would inject about 1.5 nanocoulomb whenever they do top up. So they have to go through the booster ring and get that energy up to that 1.5 nanocoulombs, and then they would top up with that.
Right.
But what you really want to have for 4 milliamp 24 bunch pulse is 15 nanocoulombs, 10 times that. So that's quite a bit more demanding. Whereas the 324 bunch mode, what they've been doing for top up is kind of commensurate with what they need for the swap out.
Yes.
So with that, I think is why they like working with the 324 bunch mode, because they don't have to address that side of the equation. But that seems to be a challenge. And you said they might have to actually upgrade some hardware to be able
Yes.
to get a bigger bunch in the booster ring, and that they can use for a swap out. And
Yes.
so when you give the numbers of flux that may be available, that's all presuming you get the 4 milliamp, which basically is a 15 nanocoulomb.
That is true. Yes. If they don't achieve that, 15 nanocoulomb or 4 milliamp per pulse, yes, then these numbers don't apply.
Then just out of curiosity, by way of comparison, you had somebody give a talk from ID9. They actually have 10 milliamps in their 4 bunch mode.
Yeah.
And they're not using a bunch swapping. I'm not sure if that's a top up that they're using.
I believe it is still a top up there.
Yeah. And so they're able to get a low emittance beam with 10 milliamps. Now that ring is a little bit smaller, so that translates to a little bit lower current. So I don't know what that means in terms of bunch current, but it's certainly more than 15 milliamp or 15 nanocoulombs anyway.
Right.
So as a time resolved beam line, we should all be haranguing management that we need to get as much bunch charge as possible as soon as possible.
Yes, the question always comes up at any sort of meeting, what's the maximum that you can get? People are asking about hybrid mode, and they said they'll explore hybrid mode more in the future, but that there are some limitations because of the direction they went with this swap out.
Yeah.
So
And I think with that choice, and they put all the effort on the main ring, and the
Yes.
booster ring is basically the same as before. But it
yes,
seems to me that that requires a little bit of a side project with good people to actually boost that, because we're talking about an order of magnitude boost of the bunch charge required to get to what their specifications are.
correct. Yeah, it's
Factors of 2 and 3 are maybe not so hard, but factors of 10.
yes, I understand. I'm because we can't get a high bunch current and we can't do top up. I'm not at this point a big fan of the swap out, but you know that decision was made, and there's nothing we can do about that part. But yes, I agree. We can continue to push to try to get higher bunch current if possible.
And then keep on reminding them what ESRF can do.
Yes. Yeah, I was a little disappointed when I realized they were able to achieve the higher bunch current still. And we can't. But okay. Any other questions or comments or
Rob, when would be a good time to test software on your new Red Hat Enterprise 9 system?
well, let's get your access figured out. But then yeah, Rena and I are doing stuff out there, but I think we can find a time where we'll stop doing our development and give you full access so that you can switch to your version of the FPGA, you can get your version of the software working. So let us know once you get access, and then I'll explain how to connect remotely. That's changed a little bit.
Okay, fine.
So, but yeah, just get access first and then let me know, and then we'll work together and make a plan. But that can be done virtually anytime.
Okay, fine.
Bob, this is Lynn. I'm sorry I was late. So were
No
you
problem.
able to share the slides with us?
We are going to put the recording online, so you can
Oh,
look at that.
okay. Okay,
So-
thank you.
yeah, no problem. Anything else? Okay, well, thank you. Thanks. Oh, yeah.
Rob, I just would like to emphasize once more that for commissioning phase, we might need some suitable experiments with longer time delays, lower current, and etc. If you have a project which is qualified for that, please contact us, Vukitsa, Robert, or myself, and we can discuss what we can do. So that's what I wanted to say in addition.
Rob, just
Hi, Ready? What's up?
hello there. Just one question. I don't fully understand. If you have this 3.6 microsecond exposure flux, which increases after the upgrade, but the single X-ray pulse flux in the crystallography mode, this decreases. Oh, it's different bunch mode. Yeah, this 8.
Yeah, you would think it would be twice as much if the with 24 to 48 bunch, but because of the lower intensity or flux within a single pulse in crystallography mode, it's not double from what we had before. So
okay. Yeah, I understand. Yeah.
Okay.
Thank you very much.
Yeah, no problem. Okay. Any other questions? Well, thank you for stopping by, and I'm sure we'll see you in, well, hopefully 6 months, but it might be a little longer for some of you.